Okay, so next is prime factorization of a number. So we will be talking about prime factorization of a number. Let's say we have, let's take a simple example. Let's say we have 100. So how we do the prime factorization? First of all, we will divide it with its smallest prime factor, that is 2. So it will become 50. Then the smallest prime factor of 50 is 2. So it will become 2 2 ja 4 25. So then I'll divide it with 5 5 1. So the prime factorization of 100 is 2 cross 2 cross 5 cross 5, right? So this is my prime factorization. So the first easy question is, let's say you are given with a number n and you need to print the prime factorization of that number n. So a simple brute force approach. Let's talk about the brute force approach first. So just wait a second. Again, street background noise. Okay. So what I'll do is I'll simply run a for loop. I will simply run a for loop from 2 to n, right? Because let's assume the smallest prime factor is 2. It may be 2 or it may not be 2. Then what I'll say is while I will try dividing this n by I, and if I get a remainder as 0. So for example, let's say n was 100. I tried and initially I is equal to 2. So I tried dividing this 100 by 2, and I will check if it's divisible. Then I will print I for sure, because I is one part of its prime factorization, right? But now what n will become? Now n will become n upon I, right? So because now this 100 will become 50, so I will say n equal to n upon I, right? Then it will try dividing it again with I. This 50, it will again try dividing it with I. So again it will print 2. Now this time n will become 25. Now for 25, this condition is false, so this loop won't work, right? So now I will become 3. I will become 3 and n is 25. So for 3 4 it will not work, so nothing will happen. But for 5, then I will become 5. Now again it's divisible, it will print 5 and n will become 5. So for 5 it will run twice, right? It will run twice, and then it will print it, right? But here it's the brute force approach though. But you can see one thing, like till 5 we are done, right? Exactly, by 5 we are done. But then this outer for loop will run till n. It will keep running, though it won't take much time, but it will keep running. So we will make it more efficient. But this one is my simple brute force. That is how you can print the prime factorization of a number. So now let's just do a little bit improvisation here. So instead of running here till n, let's run this outer loop till square root of n, and let's see what will happen. So I will say int I equal to 2, I multiplied by I less than n, and then I plus plus. And what I'll do is I'll do this same thing. While n modulo I equal to 0, I will print my I, and then n equal to n divided by I, right? N equal to n divided by I. And again, let's take the example of 100, and I need to add one if condition as well here, that if n is greater than 1, then print n as well. Okay, so now what will happen? Let's take the example of 100, right? So for first iteration it will print 2, because it will print 2. Then n will become 50. Now obviously n will become 50. Now I will become sorry, yeah, n will become 50, but this inner while loop will run one more time, so it will print one more 2. Now n will become 25. I will become 3. So 3 3s are 9. It will work because it's still less than the square root. Then 4 also, it will work. 4 4 is 16, it's lesser. Then for 5 as well, it will work. So let's put a equal to as well here. So for 5 as well it will work. So for 5 it will simply print 5, right? But then what will happen? This n will become 5, right? So if this n will become 5, now this condition is not satisfied, so this for loop will be ended. But in the end I added a condition, if n is greater than 1, then you need to print n as well. So in the end of the day it will print all the prime factorization of this number. Okay, so I guess you can see the intuition here, so you can try with any different number here as well. You can try with, let's say, 200 or 400 or let's say 150 or whatever, and some different number. What you will see is we are decreasing here n, right? We are dividing this n by I, we will keep dividing, so we need not to go beyond square root, right? Because whenever we are dividing, right, we are dividing it with its smallest prime factorization, so we need not to go beyond. Okay, so just try some few examples by yourself and it will be absolutely clear why is that happening. And in next lecture we will see again the problem is same. Let's say we need to you are given t test cases, and that is of the order 10 raised to power 5, and for every test case you will be given a value n whose constraint is again 10 raised to power 5, and for every test case you need to print the prime factorization of that number. Obviously the brute force won't be efficient, right? It will give you a tle. So in next lecture we will be talking about a technique with the help of which we can print the prime factorization of all the numbers from 1 to 10 raised to power 5. Okay, okay, stay connected.